Moving on into this video, we'll be concentrating on the priority queue. So we're going to be using what we used last time, the linear queue where we shifted things upwards, and it looked very similar to what we have a queue in real life, where we have the front of the queue doesn't move, and then as we take things off the front, everything else moves forward, so people step forward into the space preoccupied. So it was the most easy to visualize one. Priority queue does act a bit different to that. Each item that we're storing is also going to be carrying some sort of priority as well, so we know what order it can be in. So it's not just first in, first out now, it's first in, first out with some priority involved. So if we were looking to add, and sorry, I'll explain my colouring system. So I've got my red ones are the high priority ones, the yellow ones medium, and my green ones low priority. So if I was to add a low priority one, it would go right at the end. It'd go in these two spaces, a low priority one, because it can't go ahead of, it can't go into the high priority section, can't go into the medium priority section, and it can't go before the things that are already low priority. So it's got to go right at the back. A medium priority one, well, it wouldn't go into the high priority or ahead of any high priorities. It wouldn't go ahead of any medium priorities, but it would go ahead of the low priorities. So what would have to happen is we'd have to shift these two down one place and then put our medium priority one in here at the end of the medium priorities. It's the last one into the medium priorities, but it's there. And in the example I'm going to be talking about, sticking V, which is down as a high priority, well, it has to go through, find out where it needs to be inserted. So it needs to search for where we need to insert. Then we need to shift everything else down and then put V in the correct position. So ahead of the medium priorities, but behind in the queue of the already high priority ones. So we're going to see in this video some features that we've seen over a few of the videos now. We're still going to see some more inheritance, we're going to see some more polymorphism, we're going to see an enum. And the enum's a bit new for some of you. We haven't done it certainly in this video series. So an enumerated type, set of named constants with underlying integral numeric type. So it sounds very complex, but I like to think of it as giving a name to a number. So we can identify, we've got two examples here. We've got identify season, and season can be spring, summer, autumn or winter. And what this is going to identify for me is that spring is 0, summer is 1, autumn is 2, and winter is 3. And it just makes a really easy way of comparing spring to summer to autumn to winter. And because they're numeric, and because they're in an ordered numeric fashion, we can see that spring comes before summer, summer comes before autumn, autumn comes before winter. So this is going to be a really good data type for us to use for our priority. High priority, low priority, high priority, medium priority, low priority. And if we wanted to make other priorities in between, we'd just be able to add to the enum and still be able to do like numeric comparisons, but without having to remember what each number is, without having to remember that spring's 0, summer's 1, autumn's 2, winter's 3. We can use this enumerated type enumeration type, and it just makes things a lot cleaner, easier to read. And there's a second example here, so you can define what type of data it's going to be. I think by default it is an integer, I think. You can check on that later on. And if you don't write any numbers, if you don't define any numbers, by default the first one will be 0 and then they will continue. You can, however, define numbers and they will be those values. So in terms of error codes in this example, you can give different error codes dependent upon what number we're looking at, different numbers depending on what error identification we've got here. And we don't have to remember these numbers because we can just use the name of it. So it's extremely useful. Hopefully we'll see that. So our new class then. Our new class is going to be my priority queue. And unlike before, we're not going to inherit from just standard queue, we're going to inherit from my linear queue, what we did in our last video. So we're going to have that same style of the front pointer doesn't change places and the rest of the data items just move up. We are going to have an additional attribute here, and it's going to be a priority enumerated type. So it's going to identify to us what the priority of this particular item in the queue is going to be. So if we're in my priority queue, we've got our additional attribute of priority. And what changes? Well, we're going to have to change the way we onQueue. As we demoed earlier, we can't just put it at the end. We're going to have to find out where the new thing that we're adding is intended on going, and then we'll have to shift down the rest from that position and then put the data in. So I've split that process down. I've thought about the shift. Again, we did it in the last video. We made a separate method for shifting, and this time I'm going to send into it a position, so the position at which we're going to start our shift, and we are also going to do a find position. We need to find out where we're meant to be adding it. So before, where we had the high priority thing to add, we had to search through to find the medium priorities and then push them back from there. That's going to be like that. So as we said, the my priority queue is inheriting from my linear queue. So we end up with my queue that we made a while ago now, and we inherit from that in our linear queue, where we have our different way of dequeuing and shifting those elements up. And then finally, we're going to have what today's video is about, and it's the priority queue. The priority queue is going to have everything that a linear queue has, which already has everything that my queue has. So we've got all of the attributes and methods of the my queue class inside the my priority queue, and we've also got the methods that are in my linear queue inside there as well, and we've got our own attribute indicating the priority. Got an enum for priority, and just thought we're going to probably have to have that separate, because we don't want the priority for the entire queue. We want the priority for each of the queue's contents. So we're going to have an array for our enum. Priority priority array is going to hold the priorities of everything that is in our queue. It's going to have essentially two arrays. One of them, as we've been seeing, get the drawing right for this. One of the arrays, as we've seen currently, we're just going to put A, B, C, D, etc. in, and we're also going to store another array for our priority queue, which stores what priority it is: high, medium, low, etc. So we're going to have an array here that stores priority, and we're going to have to make that enum separately. If we just stored priority as a single enum, that would give the whole queue just one single priority. We want an array so we can match up position 0, position 0, position 1, position 1, position 2, position 2, position 3, position 3. So we can match up our data with the priority. Data, priority, data, priority, data, priority. So that's what we're going to be doing. So again, back to our demonstration space where we've got our linear, circular and standard queue. We're going to add a new item, a new class, and it's going to be my priority queue we're going for. And as we just mentioned, we're going to need an enum. Now, we're going to make the enum outside of the class because we want to be able to use it elsewhere. In fact, I'm going to create it in program, actually, or with the program class file. So we're going to have a public enum. So outside of the class, so we can see it everywhere. Public enum priority. Public enum priority, and we're just going to have high, medium, and low. And as the example we saw before, I'm just going to leave these without any numbers attached to them. So by default, and you can see when you hover over it, high's been given 0, medium's been given 1, and low priority's been given 2. If we did give them different values, say 4, if we gave high 4, medium just takes on the next one after that. So medium becomes 5, low becomes 6. Show you one alternative as well. If we leave high and just give medium a number, high is still given the 0, medium is given 9 because we forced that, and it then continues in succession. So there's a variety of reasons you might need that, but there you are. We're just going to leave them as 0, 1 and 2, but we don't have to remember those numbers because we can just use high priority, medium priority or low priority. So back to our priority queue, we're going to first make our properties or our attributes for this class, and we've only got the one, and it's a priority array, and we'll call it, as the suggested name, priorities. And then we've got our methods. Now we need to identify that we're doing inheritance, so we want to inherit from my linear queue as opposed to my queue. And then we need to make, just before the methods, the constructor. Constructor. Again, the constructor is always going to be a public method, and it's going to be the same name as the class. Public priority queue. We're going to have to pass in the size because we're making a queue, or we're making a linear queue, and that needed size. But I'm also going to pass in a priority as well. Because when we, sorry, I'm not going to pass in a priority. That comes later. We just need a size for now. The size of our class. The size, not of our class. Sorry, try again. The size of our queue, the size of our array that we're producing. And we've got to call the base, and the size is going to go into that. In our constructor, we are going to change the size of this array. So our priorities array is given a new instance of the priority, and it's going to be of size. Okay, so when we create this object, we'll pass in this, say again for the sake of our examples that we've done, size is 8. Our priorities array will be 8 as well. So it will match up with every possible data item. There will be a possible priority attached to it. The methods we identified, we were going to override the onKey method because we're changing the way that we're putting the data onto it. In fact, are we overriding it? No, we're not going to be overriding it, because overriding it would mean that we're using the same signature or the same amount of parameters. Now, when we onQueue something with a priority queue, we want to pass in two things. We want the actual data item, and we want the priority attached to it. So we're not overriding in that instance. However, we probably are wanting to call the base class onQueue as we go through it. So we've got that method, we'll fill that in a bit. We also wanted a shift method. And this isn't the same as the one above because we're going to place in there a position to start shifting at. And it's also different from the last one because we're going to be shifting objects to the right to be able to insert a new one. So shifting from a certain position. I'll fill that in a bit. And also, I don't know why I went for public there. These aren't going to be accessible from outside, so we should have a private modifier. Private modifier for the finding of the position. Find pos. And changing my mind about these designs, I want to pass in a priority so it knows what to be looking for. And it's going to have to return something. Just put a placeholder in for now. So we've got our priority queue inheriting from linear queue. we've got an additional properties of just the one really, an array of priorities. A constructor calls the base and also sets the size of our priority array. A method to onQueue where we pass in the character itself and the priority attached to it. A shift in which we're going to use the position that we pass in, and we're going to shift everything from that position to the right, and a method to help us find what position it should be in. And to help us find this, we're going to do what's called a linear search. So we're going to go from the first element in the array to the last, potentially last, looking for something with a lower priority than what we're passing in. And I've just thought to myself that it would be a good idea to have another priority for not set. Not set. And we can fill our array of priorities with not set. So back to constructor. We'll do something a little bit different. We'll go for a for each. For each priority P in priorities. So what this does, it's a type of for loop, it's called a for each, and it will extract each priority from this array, name it P temporarily, and allow us to change what P is. So P, when we initially construct our priority queue, the priority of all of them is going to be not set. Assigned. And we can't use a for each loop because we are changing what's being assigned there. Okay. You see how you change your mind all the time. So we're going to go back to a for loop, and it's going to go for the length of the array, which we know to be size, and our priorities at position I, we're going to set them equal to priority dot not set. So they're all going to be not sets. So that when we're looking for something, we're looking for it being a priority that's higher than not being set. Not being set, again, if you hover over it, you get a number. It's going to be our highest number. If priority is not set, we can just put our, or when we come across a priority that's not set, we can definitely input into there. So we're going to again have a for loop, which will go through. We can't use size this time, but we've got the priorities array, the priority length, and we're going and asking if the priority that we're sending into it priority is less than the priority at that position in the array. If it's less than it, it must be higher than it. Think again, if we go back to the priority enum, our high priority is 0, medium 1, low 2, not set 3. So if this is lower than the value at this position in the array, then the priority that we're sending in must be a higher value, in which case we're going to return I. because I must be the position in which we need to put this priority. If it's the same, let's say that the array contained 3 high priorities and we were trying to insert a high priority, we know high priority to be 0. 0 would not be less than 0, so it would continue to go through until we hit something of a lower priority. It returns I. Anything else, well, it shouldn't get to that point, but you need to have return paths for all of your code. So I'm just going to put -1, because that's a typical, if you can't find something, it's not there, -1. It shouldn't get to that point though. It should always be a return. Okay, find pos, I believe looks like it's okay. Next then shift, and we got shift pos. So we know what so this is when we know what position we're going to be entering the data. So we need to shift everything from that position onwards to the right. So again, for loop, but this time instead of starting from 0, we're going to have to start from pos. And again, it's going to be for the length of the priorities. But also less than 1, because we don't want the array to go out of bounds. We don't need to shift the very last thing, because that should be empty. If that's not empty, then the queue's already full, so we shouldn't get to this point. We're going to do a check for if the queue is full, so it shouldn't get to this point in that regard. So very similar to the shift that we had for our linear queue, except we're shifting the other way. So the queue contents at position pos +1 I'm thinking about this all wrong. If we put it into pos +1, then we won't be able to shift the rest of them on. So we are going to have to do a decremental for loop down until we get to the position. So that's what we're going to do. For loop for the length of our array. So queueContents.length is our starting point, or length -1. That's our starting point, and whilst I is greater than pos, less than, sorry, it has to be greater than pos, yeah. We are going to be switching the queue contents at I and setting them equal to the queue contents at I -1. So if we're at the end of our queue, we're setting our queue contents to the one before it. Now, because we're doing that to the contents of the queue, we also want to change it for the priority. So we're keeping our priorities and our queue contents in the same locations. So just doing the exact same thing, priorities I -1. Keeping track of all of those. And that should shift all of the queue contents and all of the priorities to the right by 1 place. So if we think we've got the find pos right and the shift right, it's time to do the on queue. and the on queue first test is full. Is this queue full or not? If it is, then we need to output an error message. In fact, we've got an error message that we can just copy. So the on queue overflow error queue is full. So we're going to have the same message here as well. Else, that must mean that we can put into this queue. So we need to find what position we are going to be entering this data. So find pos, and we're going to be sending through the priority that our data item has got. So that will find what position we should be inserting at. We'll also need to shift everything from that position one down. So we'll call shift at position. We'll shift them all down from the end, from the right hand side, setting that one equal to the one before it, that one equal to the one before that, and etc, etc, etc. And then we need to actually insert the data that we're trying to send in. So our queue contents at position pos need to be set to C, the character that we're passing in. In fact, I think we used to refer to that as a letter, so let's keep the same format. Just double check that. My queue. Oh no, we used C. So go back and undo it. So C, and our priority queue or priority array at the same position needs to equal the priority that we're sending in. So can we put in V with a high priority? Not if it's full, we can't, but if it isn't full, what position can we put it in at? So we go and find when the priority is lower than the priorities that we've already got so far, and we get a position. We use that position and we shift everything to the right of that position, up. So starting at the end of our queue, at the end of our arrays, we set that value equal to the value before it. And we do it for both the priority and the queue, so we're keeping our priorities with the letters that we're trying to assign. So if we're trying to assign V with a high priority, we're trying to keep them in the same positions. So once we've shifted them over, then we can insert the letters that we're trying to send, so the char C, and we can insert what priority it was. And that's where, and now is where we test it and see if it works. And with this one, I think we're going to make a heavy use of the breakpoints to test it works, because there was a few times where I changed my mind about things. So I'm less confident with this one than I have been with the others. Okay. So, just as we've done before, we're going to make a new subroutine to do our tests. Static void priority queue test. That's where I'm going to stick all the tests. I'll try and do all of the testing. And we need to declare an object, an instance of the class priority queue. And just for the sake of it, we'll stick with the size of 8. So we're making a priority queue of size 8. I think we could follow a very similar queue system. So I'm going to... No, I'm not going to copy and paste. I'm going to do it from scratch. So our priority queue, we should... Well, we should be able to assume that DQ works because... oh no. I've just thought of something we missed off. I knew this would happen. The on queue, we didn't do anything with the pointers. Of course, after we've actually placed our new letter and priority in our positions there, the rear pointer needs to increment because we've added something else. So we need to make sure that we're pointing to the end of our queue. In fact, though, we don't actually, in this case, need a rear pointer, really, because our find of the positions is potentially always going to give us the correct position to point at. Is there any time that we need the pointer? I suppose we could, instead of shifting from the very end of our array, we could instead just shift from the rear pointer -1. We'll try that. Rear pointer -1, and then that means we are still making use of the rear pointer. Try that out. You can see quite clearly in this one, it's not one I tried before recording the video. But hopefully you've seen the thought process that goes through somebody and not screaming too much at your screens about what I'm doing. So we're going to get to testing and we'll just see what happens. So we'll test the DQ initially. Again, we're going to do console write lines to test this stuff. I'm just shorten things down for this letter test. DQ1, and we're going to have priority q.dq. And we, again, just like we've done in the previous tests, we're going to identify what we're expecting. Error underflow, because we've tried to remove from an empty queue. Next up, adding to this thing, priority q.onQ. We can see here there's two things we can do now. We can do just adding a character, or we could do adding a character and a priority. Now, just being able to do the adding a character is not a good idea, because that will allow us to have a priority that's not been set for that character. So again, sorry to keep flying backwards and forwards, instead of purely just having the one on queue here that just takes a character and priority, and us being able to use the on queue from the parent classes and base classes. So again, I'll show you. We've got, it comes up and says the two overloads. On queue we've got in my queue and on queue in my priority queue, and they're overloads because they contain different amounts of parameters. The one we just made in the priority queue has a character and a priority, and the one we made in the on queue just has a character. And I don't like that, because that means that we've got something that doesn't have a priority if we just on queue with just a letter. So we're going to go back into the priority queue, and we're going to make a public void override. Sorry, public override public override, and we're going to override the onQ with a character, with just the character. And what we're going to do is simply call the onQ that we made down here, and just make the assumption that if they've just put a character in and not given us a priority, that it's going to be a low priority. Or we could assume medium. Let's assume medium. So we can now just onQ with a single letter, and what it will do, it will call the onQ with the priority, and it's got this default of a medium priority. So that when we're over here and we look at onQ, we've still got one overload, but now it doesn't point to my queue because we've overridden. So the only possible onQs we've got are in my priority queue. So we're forcing the person coding this and using this class to use the methods that we have coded in our subclass, our child class, our derived class. So that's what we'll go for first. So we set it as medium, so we'll stick in an A. And then next time we'll have a go at calling the other priority queue, priority onQ. This time passing in B, and we'll put B in as a priority that is high. So what we're assuming at this bit, so I'm going to keep in the comments this time, it's not an output, but I'm going to indicate what our queue would look like. So our queue should look like that. It should have an A with a medium. I'll do lowercase, A medium priority. When we onQ B, because we're doing it with a high priority, it should stick B ahead of A. Should. And we'll carry on testing this, so we'll stick priority queue of priority onQ, sticking with the same idea, C. Again, not explicitly putting in a priority. I expect my queue to now be B, H, A, M, and now because C was a medium because we didn't put anything in, C, M. Now the same but with DM. We should put something of low priority in. Test that works. So E will go for low priority. And you see it's much easier than having to remember what the numbers are. I know in this case it's not very complex because there's only high, medium and low, but you can get into some situations where you might want these numbers to be different than just 0, 1, 2 and 3. So we can see that enum's very beneficial. So E should go in there with a low priority. Pass in F. Fancy putting F in as a high priority. Now it shouldn't go in before the B, but it should go in before the A. So I'd expect F to be there with a high priority. So building up 1, 2, 3, 4, 5, 6. We've got 6 things in our queue. Keep going. F, G. We'll stick G in with a high priority as well, so we expect that to go in before A. And H, we'll stick it in with a medium priority. So we could have just unqueued H, but I wanted to test that we could send it through as medium as well. And we'd expect that to come out before the E, or to be placed inside the Q before the E. So that if I do a load of DQs, of course we should actually check that we should pass in an extra thing that it shouldn't fit. So I shouldn't fit, so error overflow. Because we've got to the 8th item by then, that would be the 9th, that wouldn't work. So yeah, we're going to try and DQ these and see if we get them out in the right order. So DQ2, and we would expect, based on our Q there, this to be a B. We'll just do it 8 times. Should really be doing this stuff in a for loop, but I think we've got enough to concentrate on with the difficulty of the queue systems as it is. So if we want to change these tests quickly, we can just change them up. So 4, 5, 6, 7, 8, and that one should be nope, that should be fine. We should one more for an error. And one more for an error because don't forget I started labeling these with the DQ DQ1 up here, and that's when we expected an error as well. So we expected B to come out first, then F, then G, then A, then C, then D, then H, then E, and finally error underflow again. And that's what we expect to happen. Whether it will is a different matter, but we should just go and test it. We spent enough time progressing without actually seeing if this stuff is working. So run it and see what happens. Okay, so we do get a out of bounds index, and that's because we're passing in a shift where it should be at position 1, and I has got to 8. Because very silly me, I talked about making a decremental loop but then didn't actually decrement it, I kept incrementing it. So we went beyond the bounds of the array upwards. So that should be a minus minus. The linear search, we're still searching through from the front to the back, so I did a plus plus, but in the shift, we were shifting everything from the right hand side to the highest point downwards. That's why that worked out. So don't mind errors when we can understand them. Let's have a look at what we've got here. So go back to our program and see what we were expecting. So we expected an underflow error at first, we got that. We weren't expecting an overflow error as the queue is full. Oh no, we were, sorry. Yes, these weren't outputs, these were just showing me what was going on. Of course we were. We expected an error overflow when we tried to add I, and then when we DQ'd, we expected the order to be B, F, G. I had A next. So it'll be interesting to figure out where A disappeared to. Yeah, it'll be interesting to find out where A is because it's DQ'd C there. The C, D, H and E have come through at the right order, but the A is missing for some reason. So we need to figure out why A is missing. I imagine it's because it was the first item. So why haven't we been able to add the first item? And we'll double check that stuff by putting a breakpoint in. So the point at which our test didn't work was DQ5. So we'll stop and see what's happening there. We'll run it again with our breakpoint in. So it stops at this point in the code and allows us to step through. So the queue is not empty because the front pointer is 0, the rear pointer is 5. We take a temporary copy of the queue. It takes C. So let's have a look at what the queue's got. So it's got a C, a D, a H and an E. So there's no A present there. So it's actually returning the right stuff. So I don't think it's a problem with the DQ. Let's go and see what happens when we on-queue it. So for that, place the breakpoint in, run the program, and here we go. We step into the on-queue. Because it was just a character, it goes to this on-queue method rather than this one, because that was expecting 2 parameters. This is only expecting 1. And we said that we call the other one and default the priority with medium. So, is it full? Well, the rear pointer is at 0, the queue length is 8, so no, it's not full. So we need to go and find the priority. So it starts its linear search, and we've got a priorities array that's just full of not sets, because we did that in the constructor. The constructor of this went through the full array and set them all to not set. So 0 should be not set. The priority is medium. So is medium less than not set? It is. So it should return 0, which it does. Because there's nothing in the queue, it should be put in the first position. We've then got shift pos. Shift pos, looking at the rear pointer, -1. So the rear pointer is currently 0, -1 would be -1. Is that greater than 0? No. So there's no shifting that needs to go on. We place the A character in position 0, so it does make it into the array. There's A, so no problem so far. And the rear pointer increments. So our rear pointer is pointing at 1. We've got a front pointer that's a medium priority, and the queue has got A at that position. So that's all okay so far, so we carry on. So then we're on queuing B with a high priority. So does B override A in some fashion? So it jumps straight to this method because we're passing in B and a high priority. Is it full? Well, the rear pointer is 1, the length is 8, so it's not full. If it's not full, we find out what position it should be at. We're going to the search, and we're searching position 0, which is down as medium, because A was medium. Is high less than medium? Yes. So the position that we should be placing B is at 0. So then we are shifting. We're shifting. So we're looking at the rear pointer -1. The rear pointer is 1, -1 is 0. I is 0, which is not greater than 0. So is it a case of us not shifting up enough? Should we be starting at where the rear pointer is rather than rear pointer -1? So I think that might be it. If we start at rear pointer instead, if I is at the rear pointer, we place the item, or where our rear pointer is placed, we pass in the one that's before it. So I think that's figured it out. So I'm going to remove the breakpoints and just run it and see if we do get RA. We do get RA. So it was the shifting. The shifting was incorrect. Let's just go back and see where it was incorrect. So I shifted from the wrong initial position. I subtracted 1 from that when we should be, because we're entering data into our queue at some point, we want to enter it at where the rear pointer is right now. So I shouldn't have been entering it at the one before. So that's fixed that. So let's double check that we got the output that we intended on getting. So B, F, G, A, C, D, H, E. Fantastic. They went in alphabetical order, but they've come out in a different order based upon their priorities. That is our priority queue, and it appears to be working. Do one more check. We'll try and place I after we've dequeued some. So we've got I didn't finish updating this one. G, sorry, stop running it. We've got our Q, and we enter H, and H is a medium priority, so H goes in there. H medium. If we dequeue B, and then if we dequeue B and F, our Q at that point would have no B, no F. So it's got a high priority G, and then a 4 medium priorities, so A, C, D, H, and then E low priority. So we'll just test that we can actually on-queue again. So we'll have a go at on-queuing I. Yeah, we'll keep it medium. Keep it medium there, and we expect our queue to insert an I to the end of the mediums. We'll insert another one, and it's J, and we'll have that as low priority. So we'll expect that to go to the end, to the last thing, a low priority. So this will change this stuff. Copy this. So we've added another 2 items, so we'll have another 2 DQs. So 10 DQ now won't be an error. I'll have to check what we get here now. So GQD, GQ. Say it one more time. DQing this, we'd get the G out first, so that's fine. Then we get the A, then we get the C, then the D, then the H. Then instead of the E, it would be I. And then we'd expect the E, and then the latest low priority one, the J. and finally an error because we've tried to dequeue from an empty queue. So just testing that midway through our dequeues it still works, being able to add some more things and they go into the right locations. No, come across an error. Good stuff. What's happened here? So the rear pointer is 7. Index was out of bounds. So the pos we got was -1. Okay, that's a problem here. So we weren't able to find a priority that was usable. So I think that's coming from when we try and at the end point add adding our low priority one. Because we've actually filled our list, all of our priorities have been set. We've never reset them back to not set. So everything's got at least a low priority. So it's gone and tried to search through this to find the position. There are a couple of fixes we could do. We could change the on key further. We could go and override the dequeue so that we are resetting the priorities to not set. Or we could make use of the rear pointer. So we can make use of the rear pointer again, because if we're searching through and we get to where the rear pointer is, then that is where the insertion point should be. So if priority is less than that, or can't do it on this keyboard, I'm just going to make a new if statement. If I is equal to rear pointer, return rear pointer, or return I still. So if we get to the point where we're looking at the position where the rear pointer is, well, that's where we can enter something. So we're going to return that position. So again, now really we should never get to this now. We should never get to the stage of -1. We should always find a position which the priority is less than the current priority, or we should reach the rear pointer, and if we reach the rear pointer, that's the position that we're trying to add data to. So this time, no error messages. So let's double check what we're expecting from this. So we expected an error underflow, got it. We expected an error overflow. Where did we get that one though? Yeah, when we tried to add the I, overflow. We expected them to be output in the order B, F. Then we on queued 2. We expected G to come off next, A, C, D, H. But then we expected I. So why didn't we get I? Why did we get E before I? Because I should have been inserted, it was a medium priority, so it should have been inserted ahead of E. So we'll test that by putting the breakpoint where we on queue I and seeing what happens. So it stops and allows us to go through the code. Is it full? No, not full. So we need to find the position that we're trying to insert into. Let's have a look at these priorities. What have we got? We've got high, 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 medium, 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 low. Double check that that's what we're anticipating having. So program at this point, we're anticipating having this array. So we're expecting, apologies, we're expecting our priorities to be high, medium, 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 low. And we've got multiple highs. Okay, so that's a strange situation to be in. We weren't expecting it to look like this. What does our queue contents look like at the moment? GA. So when it goes to insert a medium priority, it's going to be put in position 7, or whatever the rear pointer is, 6. So it's going to be put in position 6, and position 6 would be after the E. So before this point, we must be incorrectly shifting or not shifting the priorities in the right way. Okay, so paused recording the video there to try and figure it out to not waste more time in front of you. It didn't take very long. What I found was happening is, I think all of our priority queue stuff is working now, but because we didn't do anything with dequeuing, because we said, oh, the dequeu's in the linear queue, it works, we're happy with it. The dequeue shift, of course, didn't do any sort of shifting of priorities. And why would it? It was just based on queue contents. So our priorities were never getting shifted. So we're going to have to come up with a way of shifting our priorities. So what we're going to do with that is we're going to change this access modifier to protected, and make it virtual so we can override it. And we still want this to happen. It's just we also want our priorities to be shifted up as well. So I'm going to just take a copy of this so I remember what I need to do. So in my priority queue, we are doing more than we first anticipated. So we are override shift, protected override shift, sorry, again, yeah, protected override shift, so that when the shift is called, it goes to do this one. We still wanted to do our base, a base shift, which is like that, but we're also going to do it for the priorities as well. Just substituting these words for the priorities. And the priority, I think we mentioned it before, it'd be nice to just set the last one to being not set. Don't have to do it, of course, but it makes a nice endpoint. So the shift will do this one rather than the shift that we saw before. Well, it still will do the shift we saw before because we're still calling the base class shift, but after it's done the base class shift, so after it's shifted all of the letters, the queue contents, it'll go and shift all the priorities, and that should fix our issue. Of course, doing it without testing it first, and we've got breakpoints in, so we'll continue. Do we get the result that we're expecting this time? So we output B, F for output, G, A, C, yeah, it's matching, D, H, I, this time I has come out before E, and J is outputted as DQ'd as the last one. So it is working. It is working, and we just do want to put a little breakpoint in to see some of that in action, just to see behind the scenes. So when we're doing a DQ, it's going to be shifting the queue contents. So the queue contents should be shifted up. Oh, we wanted to see an on queue, really. Sorry. I'm going to go watch an on queue. Not all the way down there. Let's watch a medium on queue. Watch I being put on. So we'll run it, and you can do any tests you want and any breakpoints you want that help you along the way. So we're testing it on queue. Is it full? We'll walk through it. The rear point is 6, the length is 8, so it's not full. We need to find out where this new character, this I, should be put in when its priority is medium. So we do a linear search going through. We look at our priorities. We've got 1 high, 1, 2, 3, 4, 5 mediums, then a low. So it should go in at position 5. We should be looking to put it in there because this is a medium priority, so it should come before the low priority. So it goes around and searches. You notice down here we've got I incrementing each time. I becomes 4, still not right. I becomes 5 now. So we're expecting, yeah, and it's right, we're expecting it to return 5, and it does. So 5 gets returned. So that means we're going to shift from position 5. So the rear pointer is pointing at 6. So we're looking for 6, which currently is blank. We're looking for E to go in there. And in our priorities, position 6 is not set. We're looking for the low to be pushed into the priorities. So we run that code and we see that E has been put into position 6 and low has been put into position 6 as well. Now currently we've got E in there twice now, but when we return to where this was called, because we've done the shift first, now at position 5 we're inserting whatever C is, which is I. So our contents should now have changed after that line. So I is now in position 5, and our priorities, we've got another medium in position 5 now, and low has been pushed down to 6. So eventually we've got our priority queue made. It involved a few interesting things along the way. It involved us creating a linear search in order to go through the array and find the position that we should be entering it, and it involved us shifting, using a decremental loop, shifting items down the queue when they've got a lower priority than what we're looking to enter. And we also included using enums, which makes things a heck of a lot easier. So if we wanted to insert all of a sudden other different values, so things like very low or very high, we're not going to have to go through the code and change lots of different things. because our very high is going to be our 0 now. So it's going to be less than high, less than medium, less than low, less than very low, less than not set. But we're not having to change loads of different code. We can just make those changes really quickly and it will work. So I just want to show you that all I did was add very high to this and very low. And if we change up some of this so that when we enter when we enter F, we'll have that as being very low. So F will no longer be there in the queue. It'll be at the end, V low. And if we enter G as V high, very high, we'd expect this queue to look at this point, the queue to have the G at the front, G with a very high. Where would H go? Well, H is coming in with a medium, so it's going to go at the end of the mediums. H, medium. Carry on this through. If we DQ'd, if we DQ'd now, we'd expect G to come off first, not B, then B. So G and B have come off. Copy, paste, and then we're on queuing I with medium. So medium, I should go there with medium, and then entering J with low should come before F, that's very low. So J with low before F. And then we would be expecting A output, then C, then D, then H, then I, then E, then J, and finally F, in that order. And this is where we cross our fingers, because this can be the end of the video if it works. So we have a look at what we're expecting. We're expecting G to come out first, we got that. We got B second. We've got A third, C, D, H, I, E, J, and F last, because that's down as very low. And all I had to do was change that one enum to also include very high and very low, and all of a sudden we can use those. So extremely powerful and good techniques using enums. That will be the end of the video.